Thank you. So this talk is called Dry Deployments with Terragrunt, where dry stands for don't repeat yourself, which is not always a good thing in PHP, but it's a nice to have when you're doing infrastructure code. So about myself, my name is Vitor. I'm a software consultant at Noise Labs Consulting. My Twitter handler is Noise Labs, and my blog is noiselabs.io. So let me start by just disappointing the entire audience. This talk is not really about PHP. Maybe that's why I'm first. In fact, you won't see a single line of PHP code throughout the talk. Instead, what I'll be talking about is a couple of infrastructure tools that you or your team could use to deploy code and how to not repeat yourself while doing so. So let's get started. So the code that you're working on probably is going to end up in one of these cloud providers, right? Everything is going to the cloud. So the big ones being AWS, Azure, Google Cloud, DigitalOcean. And if you don't see your favorite cloud provider there, my apologies. And if you're deploying to one of those cloud providers, chances are that you or someone in your team is using a tool like Terraform. So Terraform is, and I think I lost focus again. I'm back. Cool. So Terraform is an open source infrastructure as code tool written in Golang. And when I say infrastructure as code, that means that you can describe your infrastructure in code, which means you can commit that to version control. So you know what changed, when it changed, who changed it, and you also know what is there and what shouldn't be there. It is, you write code using the HCL Terraform language, which is a declarative language. That means that you set what the end result should be. You don't specify the how to get to that end result. You just tell it what you want it to be created. There are something called Terraform providers. So Terraform providers are plugins, they are adapters that know how to talk to a specific cloud provider. So let's say you are working with AWS, so you'll be using something like the Terraform AWS provider, and that's basically just some code that knows how to talk to the AWS HTTP APIs. So basically that's how it works. And finally, infrastructure provider is considered immutable. So I'd like you to consider this scenario. You're working on you have a WordPress application. I see some frown faces. And you want to deploy that to the cloud. And I'm taking AWS as an example. So you want to deploy that to AWS. So one solution that you could use, you could Dockerize your application. And because it's Dockerized, you can simply replace WordPress with Laravel or Symfony or any other PHP application. Doesn't really matter. And Amazon ECS is basically Amazon's Docker solution in the cloud. And of course, it could be repurposed as something else. It could be Kubernetes, etc. So consider this scenario. The diagram for implementing that solution could be something like this. I hope it's not too scary. So we could have our ECS cluster, and inside we have our WordPress containers running. In ECS terms, each one would be called an ECS task. We also need a database, and we need a few network components. I've thrown in a load balancer, quite common, and a public and a private subnet, and a VPC, a virtual private cloud. So this is AWS specific. So this is the scenario we're going to work on. In order to have this created, using Terraform, I would start by writing Terraform modules. So Terraform modules are the building blocks, small components written using Terraform files so that I can create that infrastructure. So one way to create that is by splitting into three different modules. So I could have my networking module, a website database, and a website ECS module. And on the right side, you can see an example of what the website ECS module could look like. So I could put, so it's just really a folder with Terraform files inside, with .tf files inside, and I could have my ECS related resources in that ECS file, the load balancer. Then I'll have my inputs in my variables.tf, and the values exported by the module in outputs.tf. And you don't really need to specify the files with these names. It's just some sort of convention. So this is my Terraform module, which is the basic building block. And if I take a sneak peek at my ECS.tf file, I can see that basically what it does, it starts with the word resource. So it's going to create a resource in the cloud in AWS. In this case, it's going to create something associated with a task. So this is a task definition. So notice how I'm referring a Docker image that I've pushed earlier to the AWS Docker registry, which is called ACR, with my WordPress container. I'm also passing in some environment variables. So telling WordPress where to find my database, the name, credentials, and a few other things. If people have used Docker Compose, this definition is actually quite similar to Docker Compose. Of course, this file will have a lot more resources inside. This is just an example of what the Terraform code looks like. Now, the Terraform module is not sufficient to actually create the resource. Instead, I need something more, and I need what I'm calling a component. So you can think of the module as a PHP class declaration, and the component as instantiating that class. So in my example, I've created two components, a network and a website component. And on the right side, again, just a bunch of Terraform files. Most of my code, I've put it in that main.tf. I also have the same outputs.tf, the same variables.tf, and a few extra files that Terraform requires me to create. So this is an example of a Terraform component, a file inside my Terraform component. So I'm consuming my two modules, my database module and my ECS module. And note how I'm in the ECS module, I'm using the outputs from the previous module. So that's how I'm getting those values. And in this scenario, I'm referencing my networking component, which is a different component. And the way to do it in Terraform really is use something called a data source remote, Terraform remote state. That's how I can peek into the networking component. And it's sort of an implicit way to get values from a different component. Now, Terraform requires me to actually write a bit more of configuration. So I also need to define where to find the Terraform state file, which is a file in which Terraform records a collection of all the resources created and all the outputs created, which if you're working in a team, you're probably going to store that remotely. So given that this is an AWS example, I'm just using an S3 bucket to store my state file. If you're a single developer, you could just store it in your laptop. And on the right side, I have my providers.tf, in which I just define the providers I need, so they can get installed, similar to a composer.json, and also some version constraints. So it's a bit more of extra configuration that I need to add per component. So in IT, we like to make things complicated and complex. So obviously there is not a single environment. Probably there's a few environments you're going to use. I've thrown in 3 environments. I've been on projects where they use a lot more than 3. So you probably at least will have a development environment in which you're going to do your development, your testing, a QA environment in which your product owner is going to sign off your work, probably, and your prod, your production, your live account, where you actually will have your application ready for your clients. So on the right side, if you just look just at the website component, you can see that there are a lot of files. So this can grow very rapidly, and it can get very messy very quickly. So, and there is a lot of repetition in those files. So how do we solve this? The clue is in the talk title. I'm suggesting Terragrunt. So Terragrunt is a thin layer that sits on top of Terraform. Doesn't replace it, we'll still need both, but it will simplify things. So with Terragrunt, we'll define some of the Terraform code just once, basically the modules, and it's regardless of the number of environments that you will have. So we can get rid of duplicated backend code, duplicated providers code, and we can use inheritance. So if you remember the previous example, this is what it looks like with Terragrunt. So for each component in each environment, we'll have now a single Terragrunt HCL file, and we'll have a top-level Terragrunt. And this will be the file in which I'll put my backend and my provider's configuration. So this is an example of a Terragrunt HCL file. I'll still point it to a module, to a single module. Here, I'm just saying I can inherit everything that has been defined in the Terragrunt files that got defined above. So I'll just inherit everything for free. And I get explicit dependencies. So here I'm saying I need that networking components have been created and applied. I need the website DB to have been created and applied. And finally, I can just inject all of those outputs into my website ECS module. And that's basically the entire Terragrunt file. So in summary, the benefits of using this tool is that we get rid of repeating Terraform configs, so prototyping gets a lot quicker. There are less copy-paste mistakes because there are less files to maintain. We get environment variable support, and this is quite a powerful thing because this means that you can, using external tools, so PHP, Python, you can generate values externally, so the database name or etc., and you can just inject that into your Terraform and Terragrunt code. It's quite easy to apply tags to every single resource created in the cloud. So you know this got created by Terragrunt, by this version of Terragrunt, and so it's managed in code. It's quite easy to do that. We can run custom code before we apply it to Terraform. So the way Terragrunt works is that Terragrunt will internally actually call Terraform. So before calling it, we can run some hooks. We can generate files and read from files. And this is especially important to software developers. We get explicit dependencies. So we can have a sort of dependency injection, which I've noticed software developers value a lot more than maybe pure WebOps engineers. And because of that, testing becomes much easier. And I'm making a special reference to that tool, TerraTest, which this is a Lightning Talks, and I'm not going to talk about it today. So just before wrapping up, a few resources I'd like to share, links to the Terraform and Terragrunt websites, a good collection of high-quality modules for AWS, Terraform AWS modules, and the TerraTest tool, which I really encourage you to have a look because it allows you to do testing of infrastructure code. And that's it. That's the end of the talk. Thank you very much. I hope you have enjoyed it. And I'll be around for questions. And of course, here's the joined in link for feedback. Thank you very much.